Okay, so I thought we'd do a vectors question from the Pure paper, from 2022, Pure paper 2. I know vectors can be a tricky topic for some people, so in this question here we have points A, B, and C. We know they're position vectors relative to a fixed origin. So remember, position vectors really just means it tells you the coordinates of the point. So for example, if O is the origin 0, 0, 0, then A is the point 4, negative 3, 5. Now, as a vector, you could sort of represent this as OA equals that vector 4i minus 3j plus 5k. Now I'm going to write all my vectors in this question as a column, much easier. So OA is this column vector. OB similarly, now 0i plus 4j plus 6k. And then OC negative 16, p and 10. Okay, so position vector is just putting the coordinates into a vector. It's telling you how to get from the origin to that point. Now it says that ABC line is a straight line. So what we have is A, B, and C in some line. And now O is the origin. O could be anywhere, so don't make the mistake of just sticking O over here. Right, O really, I don't know where it is. I'm going to put O down here. Okay, so OA be this vector here, next to O and A, which was 4i minus 3j, 5k. Okay, so this is the picture. And then we have similarly, we can have OB. That's not worked. OB and OC. I won't write them all in just here, but you could label them all if you wanted to. So we're meant to find P, find the value of P given that they lie on a straight line. Well, if you remember from GCSE vectors, when you have 3 points lying on a line, what that meant was that the vector AB would be parallel to the vector BC, or AB parallel to AC. Right? If ABC is some kind of straight line, then these two vectors should be sort of parallel to each other. So, can we figure out AB? Yeah, AB, we know. I mean, you should just learn this method, right? From A to B is sort of A down to O, and then O up to B, which means I'm doing AO plus OB, which is negative OA plus OB. So negative OA would be negative 4, positive 3, negative 5, plus OB 0, 4, 6, which is negative 4, 7, and 1. Okay, so we know how to go from A to B. It's this vector here, negative 4, 7, 1. The thing about these vectors AB, the way to calculate it, this subtraction, it is also intuitive rather than taking this long path. If you think about the coordinates of A is 4, negative 3, 5, and the coordinates of B is 0, 4, 6. Right? So it is intuitive that to go from A to B, look, my x coordinate decreases by 4, which is why I have negative 4 here. And the y coordinate goes from negative 3 up to 4. Y coordinate increases by 7. And the z coordinate goes from 5 to 6. So z coordinate increases by 1. Right? So it is a logical idea. Anyway, so we can speed through the rest of this. This can be very similar. So AB is negative 4, 7, 1. BC, do the same thing. We will do negative OB plus OC. And what will we get here? We will get 0, negative 4, negative 6 plus negative 16p10, which gives negative 16, negative 4 plus p, and 4. Cool. And we know that AB and BC are going to be parallel to BC. What is AB? AB was negative 4, 7, 1, parallel to negative 16, negative 4 plus p, and 4. Now remember vectors, when we say vectors are parallel to each other, that means that they are a multiple of each other. So for example, the vector 1, 2 is parallel to the vector 10, 20, because I've multiplied it by 10. Now, you can set up an equation with k here if you want. You don't actually need to. Hopefully you can see pretty quickly that to go from my vector on the left to the vector on the right, I need to multiply by 4. Right, the x component go from -4 to -16, and the z component go from 1 to 4, multiplying by 4, so I know that 7 times 4 needs to give me -4 plus p, which will tell me that p is, what's that, 32. And yeah, you could have written that -471 is k times, and you've got k equals a quarter here, and then you solve for p. It's the same idea, but a little bit of a shortcut. We don't need to write all that out. B, let's do part B. So B says we're going to extend the segment OB to a point D so that CD is parallel to OA. Find magnitude of OD. So here, because it's going to be a little bit cluttered to do in this diagram, let's just draw a new one. Okay, so new diagram. I'll sort of repeat what we have. We had O, A, B, C. A, B, C with a straight line, and it said the line that OB is extended to D. So D is somewhere out here, such that CD is parallel to OA. So CD parallel to OA. Well, here's OA. So D will kind of be out here, right? It's on the line OB, but OA is parallel to CD. Now, what do we know? We know OB. We wrote that on before. That was 0, 4, 6. And OA we knew 4, -3, 5. How can I find my point D? Right? What do I know about D? I know D is certainly sort of on this line OB. Now, if you look again, OB and D in a straight line, that means that OB will be parallel to BD, or even parallel to OD, right? Because it's all on a straight line. And in fact, what this tells us is that OD is just going to be some multiple of OB. I'll call it lambda. You could call it X or Y or K again. It doesn't matter. But OD will be some multiple of OB, because if OB is here, and OD is just sort of extending that to a longer vector in the same direction, that's a multiple. Okay, so OD is going to be some multiple of 0, 4, 6. So it'll be 0, 4 lambda, 6 lambda, right? So I've multiplied this vector by lambda. So that's one thing I know about D. I know it sort of extends the line OB, so it has to be written like this. What else do I know about D? Well, the thing I know about D is that CD is parallel to OA. So let's write all this out. CD, I can get, well, I know how to go from C to O, and I know how to go from O to D. I've just written that down. So CD I can figure out. CO, what was C? C was -16 P10 to -16 32 10. Now I've had to negate everything here because I want to do CO and not OC. Plus OD, which we've just written down, that was 0, 4 lambda, 6 lambda. So CD is given by 16, -32 plus 4 lambda, and -10 plus 6 lambda. And we've been told that CD is parallel to OA, which we have as before is just 4, -3, 5. So again, either setting up an equation or just having a look at the scale here, I can tell from the x components that the scale is again 4. Okay, so this is going to actually give me 2 equations here. So hopefully they're going to agree. Let's get those in and check. So my first equation, if I look at maybe the z component, 5 times 4 is -10 plus 6 lambda, which would actually to this is 20, 20 plus 10 is 30, 30 divided by 6 lambda is 5. I could have also looked at the y component, -3 times 4 equals -32 plus 4 lambda. I think the same thing here, -12 plus 32 is 20, 20 divided by 4, again lambda equals 5. So really, either one of these, I know that lambda has to be 5, which means OD will be 0, 20, 30. So I found my coordinate of D. And just to emphasize or repeat the thought process I went through, to find the coordinates or the position vector of D, I said, well, what do I know about D? What does the question tell me? How does it define where D is? D is, on the one hand, somewhere in the line OB. So on the one hand, I can write it like this. And on the other hand, it makes CD parallel to OA. So that gave me this relationship here. Okay, and combining the two enabled me to find the exact position of D. Okay, so let's just answer the question. It says find the magnitude of OD. Writing answer is fully simplified third. So I just need to take the magnitude vector, which hopefully you're familiar with by now. We do the Pythagoras trick, right? The square root of 0 squared plus 20 squared plus 30 squared. Well, you can do whatever you want here, put in your calculator. You can also factorize out to 10 initially, which I'm going to do now because my calculator is not on me. That's 10 times the square root of 0 squared plus 2 squared plus 3 squared. So I get 10 root 13. And are there any units here? We don't have any units, so I will just leave my answer 10 root 13. Hope that helps. And any past questions on vectors that you'd like the video on, let me know. I'm very happy. Or just maybe more like an overview of the whole topic if you're really struggling. All right, thanks.